Hi, my name is Bella Keller, and I am the lead programmer for Team 1425 DuBois area.
And I am Nick Evans, a junior programmer.
This is our Simulink model for the 2024 Best Robotics season, Low G. We took full advantage of Simulink's simulation system using the signal bus to route signals to each portion of our code to test during development. Firstly, we decided to use a four-wheel tank drive with a rotating and extending arm. For our drivetrain, we have a custom MATLAB function which reverses the direction of the drive orientation. We also implemented deadbands for better joystick control. The nonlinear mapping function allows for more precision at lower speeds without cutting off our max speed. In the same function, we implemented a speed cut which adds even more precision at lower speeds, but it does cut off our max speed. We then implemented a motor hold to make it so it's easier to do tasks on the uneven rough terrain. When the motor hold is activated by the driver, it stores the motor values to memory, which then makes it so the motor holds without input from the joysticks. This function allows for temporary override of the hold if needed. For the arm, we used a simple state flow that cycles through the up, down, and off states. We also have it so when the direction is switched, it also switches. We also have a rate limiter for smoother motion changes.
We also added an autonomous routine that raises the arm while the driver is placing the remote down for the spotter to interact with the robot. This saves us a few seconds for the Hoberman sphere us. As the drivers worked with the robot and got worn in, they noticed that the arm would fall while extended or with a load. To address this, first we added a simple constant motor hold. This worked, but not in every situation. So it evolved into a 4-level hold that was adjustable at the driver's discretion. While this worked better, it still wasn't ideal, and we decided to add a potentiometer to measure the arm's position and use PID controller to hold the arm in place with exactly the right motor signal required. We also added a manual override so that this could be turned off during practice sessions or while setting up the robot. Our arm extension is controlled by 2 digital buttons that transition a state flow between 3 states: extend, retract, and off. Compound transitions ensure that button mashing has no impact. Our habitat latch is used to deposit a detachable container into scoring position. It is controlled by a single button on a latch that simply moves the servo between open and closed states. We have the button on a slightly longer sample time to reduce the risk of accidentally deploying the container.